Hello there, and welcome to Sleepy Cosmic Podcast, where we wander beneath velvet skies, following ancient light on its unhurried path through time. Tonight, a strange visitor moves silently near Mars. Its name is 3 Atlas, and something it just did has unsettled even the most seasoned sky watchers. We're not here to worry or rush, just to drift beside it for a while and wonder, gently, what it might be trying to tell us. You might picture this as you settle in, a slow speck gliding through blackness, barely brighter than the dust behind it. Mars hovers nearby like a tired ember in the dark, and we, on our little Earth, are listening. We're always listening. If this kind of quiet wonder helps you rest, I'd be grateful if you tap like or subscribe. No pressure at all. Wherever you are right now, we'd love to know your location and local time. Maybe it's late, maybe early, doesn't matter. The universe has time for all of us. Now, dim the lights, maybe turn on a fan for a soft background hum, and let's ease into tonight's journey together. 3 Atlas. First caught our attention as a curiosity, an interstellar object. The third ever officially confirmed. Not born in our solar system, not tethered to the gravity wells we know. It came from somewhere else, and it won't stay long. That alone was enough to merit a hush of awe among astronomers. But what it did near Mars, that's what makes this story different. Mars is, in cosmic terms, close by. It shares our star, has its own moons, and bears the scars of old oceans and wind. Its skies are thin, its surface red with iron and time. So when 3i Atlas slipped into its neighbourhood, we expected a brush by, a smooth arc, nothing disruptive. But the instruments began to whisper something else. At first it was just a soft brightening, not dramatic, nothing to cause headlines. But it happened too quickly. Its light curve, a quiet graph of reflected sunlight, jumped. And it didn't match its rotation or trajectory. It was as if it had blinked at us, a flicker in the stillness. Most comets and interstellar objects are known for this kind of variability. They're loose, dusty, volatile things. But the timing, that was odd. The moment it neared Mars' orbital path, something changed. Some think it could be outgassing, simple sublimation as ice meets sunlight. Others suggest it passed through an invisible pocket of solar wind or magnetic turbulence, a push, a tug. But none of that explains what came next. Instruments trained on it from Earth and orbiting telescopes began to report subtle deflections. Not massive, but noticeable. A change in vector, the kind that suggests it interacted with something, or altered itself. Imagine watching a bird glide through still air, and then, mid-flight, it shudders, changes course, and continues on. That's what 3i Atlas did. A course correction, perhaps, or a reaction, something reactive, something alive with physics, if not with life. Mars at the time was trailing slightly behind it in orbit. But even that position, the spatial relationship, felt uncomfortable. Too close for coincidence, and yet so vast we couldn't quite grasp the scale. Millions of kilometers between them, but in the ink of space, even that can feel like proximity. It's worth remembering that we've seen interstellar visitors before. Oumuamua came first, all tumbling and silent and long, then Tui Borisov, brighter, more comet-like. But this third, 3i Atlas, seems quieter, trickier. It moves with a kind of reluctant grace, as though it's aware we're watching. That's not science, of course. That's our human pattern-making, painting emotions onto rocks and ice. But it's hard to ignore the timing, and as we drift alongside it in thought, it invites a kind of reverence. Mars itself has no say in the matter. But we wonder what it might have seen. If a passing comet could briefly ignite its sky, if ancient dust fell into its atmosphere, if something, somewhere, registered the change. The red planet has been the setting for many strange observations, long before spacecraft ever arrived. Glints, lines, flares. We now know most were illusion or misunderstanding, but still the mythos remains. Mars is where we project movement, emotion, war, and now, perhaps, witness. We'll stay here a little longer, with Three-Eye Atlas in mind, with Mars below it, with Earth watching. Whatever just happened near Mars, it may not be terrifying in the cinematic way. But in the quiet realm of deep space physics, it's enough to raise our eyebrows, to make us adjust our scopes, to make us hush and pay attention. The sky just changed a little, and we felt it. It began with a flicker, faint, hesitant, almost ignorable. A shift in brightness that barely registered, except to the kind of instruments designed to notice such things. But then came another, and another, until the pattern broke the still rhythm expected of a quiet traveller drifting near Mars. Our telescopes, orbiting high above Earth and scattered across deserts and mountaintops, turned slowly toward Through-Eye Atlas. Some were optical, collecting visible light. Others gathered the invisible, infrared signatures, radio waves, ultraviolet scatter, and across these frequencies a strange chorus emerged. The light wasn't stable. Not in the way we expected. At first it was possible to dismiss. Objects like this can tumble, especially if they're oddly shaped. Brightness may fluctuate as different surfaces catch sunlight. But these fluctuations didn't match the expected spin. They were abrupt. Not chaotic, but intentional in rhythm. Like a blink, then a pause, then another. You might imagine a candle across a vast field, flickering not with wind, but with breath. It's that kind of fragile disturbance that caught our attention. The observers began to model it. Rotational dynamics, albedo changes, sublimation events. Perhaps some volatile material exposed itself. Or maybe a fracture caused sunlight to catch at a new angle. These are familiar ideas in the realm of cometary science. But 3 Atlas did not behave like a typical comet. Most interstellar visitors like 2I Borisov arrive fast, blaze briefly, then fade. This one, however, slowed near Mars, at least in angular motion. Its position relative to the red planet tightened. Not in impact terms, nothing that would worry mission controllers, but enough to warrant a longer look. And that's when deeper instruments, the space-based arrays, began catching something quieter. The James Webb Space Telescope, built for patience and nuance, caught spectral anomalies, not strong enough to suggest outgassing, but not passive either. Tiny fluctuations in heat signature, as though some surface was being altered, not evenly, not over time, but in sudden, jerky transitions. What kind of object behaves this way? We often imagine asteroids and comets as leftovers, cosmic crumbs. But some carry complex histories. Some may have passed through star systems. Others might have grazed the edges of gravity wells that shaped them in strange ways. And a few, just a few, might be more than leftovers. They could be fragments of something older, something shattered long ago. In the case of Three-Eye Atlas, it arrived on a hyperbolic trajectory, meaning it's not bound to our sun. That alone confirms its interstellar nature. But that trajectory, once thought smooth and predictable, now seems to be bending. Of course, gravity from planets can cause that. Mars isn't massive like Jupiter, but it still exerts influence. Perhaps we're just witnessing a gravitational nudge. Perhaps. But models show the change isn't entirely accounted for by gravity alone. There's a residual, a difference between expected and observed. Small, but unsettling. And the light pattern, it's not consistent with known comet types. Some observers now speculate we might be seeing fragmentation, a piece breaking off, or a surface collapse. If so, it happened very close to Mars. Others go further, suggesting we may be seeing an object reacting, however passively, to an environmental cue. Solar wind, electromagnetic flux, or even Mars' faint magnetic tail, a leftover echo from a once active planetary core. Still, the brightness pulses raise questions. Could they be rotational beacons? Unlikely. Could they be natural reflectivity shifts? Perhaps. But the rhythm is strange. If you look at the raw light curve data, it looks almost musical. Not perfect, but patterned. Like distant echoes bouncing off terrain we cannot see. It reminds us of Oumuamua, whose odd acceleration sparked speculation. Many argued it was just outgassing, hidden by its shape, but others saw something more deliberate in its movement. Three-Eye Atlas brings back that conversation, softly and without conclusion, and so we wait. We turn our scopes night after night, tuning in like patient listeners, waiting to hear the next note in a drifting song we do not yet understand. There's a kind of humility in watching the skies like this. It reminds us how much we don't know. Even with decades of missions and decades more of data, we still struggle to explain the behaviour of a single visitor. Some suggest it may have a binary structure, a core and fragment dancing slowly, too faint to resolve. Others believe it may have hit debris, a micro-impact triggering the change. A collision in space isn't like a crash on Earth. It's slower, quieter, but the consequences can echo for hundreds of thousands of kilometres. One proposed theory involves a dust sheath, an envelope of particles surrounding the body that could have been briefly disturbed as it passed through Mars' orbital wake. Dust particles reacting to invisible currents, or collapsing into tighter orbits around the main object. It's beautiful to consider, in a quiet way, that even dust in space has choreography. Whatever the cause, telescopes continue watching, and we, in turn, listen to those instruments. Not for answers just yet, but for continuity, for rhythm, for understanding that builds slowly, like layers of sediment at the bottom of a still lake. We might not know for months what truly happened near Mars, or perhaps we never will, but we saw it, we felt it. Not with fingers, but with photons, carefully caught and patiently studied, and in the great silence of space, that alone feels like a form of contact. Out in the dark, gravity is the quiet hand that shapes everything. It does not shout, but pulls. It bends light, sculpts orbits, and guides even the loneliest wanderers like Three-Eye Atlas through the black seas of space. When Three-Eye Atlas drifted close to Mars, something subtle began to happen. A slow reshaping, a gentle tug that changed its path in ways not entirely expected. Mars is small compared to the giants of our solar system, but its gravity still reaches outward with invisible fingers. As the object approached, it fell ever so slightly under that influence. Orbital models began to shift. Tiny course corrections showed up in data, pushing analysts to refine their simulations. It was as if the visitor dipped a toe into a shallow current, and that current nudged it just enough to cause unease among those tracking its journey. Gravitational assists, or slingshots, are common in space navigation. We've used them for decades to send probes deeper into the solar system. A pass near a planet accelerates or redirects a craft without using fuel. Nature offers this gift freely, though it obeys strict laws. But 3 Atlas didn't behave exactly like a spacecraft. The way it reacted to Mars' presence wasn't clean. The curve of its arc flattened slightly more than it should have, as though something softened the pull. Some researchers wondered if it wasn't a single object at all. If a loose cloud of debris surrounds it, too faint to see directly, then Mars's gravity might have tugged on different parts unevenly. The result? A kind of gravitational smudge, a slow distortion in path, not from mass but from structure, like wind dragging a veil through the air. Others have proposed that the shape of 3-Eye Atlas itself is the culprit. A highly elongated object would present varying surfaces to Mars's pull, depending on orientation. If it's tumbling in a complex way, what physicists call a non-principal axis rotation, then the gravitational interaction becomes harder to model. It's here that the mathematics gets poetic. Picture this, an object shaped like a shard, tumbling through a planetary gravitational field, with faint jets of sublimated gas erupting at uneven intervals. each force minute, each impulse delicate. But across days and millions of kilometres, those small whispers of motion add up. It's a dance of unseen steps, written in orbital equations and radial velocities. Meanwhile, Mars itself continues on, unbothered. It spins under a rusty sky. Its two moons, Phobos and Deimos, carving lazy loops overhead. Somewhere above, 3i Atlas passed by, and the planet felt it, barely. But the dust, the sky, perhaps even the faint wisps of atmosphere, registered something. If dust fell, it would be microscopic. No rover would find it. But the idea that something ancient and interstellar rained briefly onto Martian soil is haunting. There's another layer to this story, tucked into the Lagrange points. These are regions of gravitational balance where objects can remain relatively stable, trapped between the competing pulls of larger bodies. Mars has several such regions. If 3 Atlas passed near one, it may have hesitated there, however briefly. A moment's pause in a place of equilibrium, a place where even gravity seems to hush. Of course, this is speculation. The trajectory, as reconstructed, doesn't suggest a full stop, but the proximity to Mars's orbital plane and its Lagrange regions raises the question, what else might be hidden there? It's easy to forget how crowded space can be. Mars has its own Trojan asteroids, small dark bodies that share its orbit. Perhaps 3i Atlas passed close to one, unseen, triggering the shift. Or perhaps a fragment from a forgotten collision, dust-sized, but enough to tilt its course ever so slightly. Then there's the Sun, always watching, always pulling. Its influence stretches far beyond the planets, shaping comet paths and solar wind alike. Some theorists suggest the change in trajectory may not be entirely due to Mars, but a resonance between Martian gravity and solar influence, like two waves overlapping to create an unexpected push. In deep space, cause and effect can blur. What remains clear is this. 3 Atlas did not simply glide past Mars in a straight line. It bent, it hesitated. Its arc was redrawn by gravity's soft insistence, and for us, that's a reminder. A reminder that space isn't empty. It's full of fields and forces, histories and hints. Objects like 3i Atlas are shaped not only by where they are now, but by where they've been, what stars they've passed, what forces they've felt. We may never know what shaped this visitor in the eons before it reached us. But for a brief moment as it passed Mars, we saw a new chapter written, a slow-motion gesture captured in numbers and curves. And as we lie here tonight drifting beneath our own sky, that gesture still unfolds, still bends, still echoes outward. It wasn't just the gravity. Something changed, abruptly, and in a way that left astronomers uneasy. A brightening, yes, a shift in trajectory perhaps, but it was the combination of changes, all clustered around the same short window near Mars, that transformed curiosity into quiet alarm. Brightness changes are expected in comet-like bodies, as volatile ices sublimate, turning straight from solid to gas. They can spew out jets of material that reflect sunlight, producing a flickering glow. But what we saw from 3i Atlas wasn't a steady outgassing signature. It was sudden, sharp. It flared and then dimmed, like a match struck and quickly blown out, and then it brightened again. Across multiple observatories, in different hemispheres, using different instruments, observers recorded irregular peaks in reflected light. Not chaotic, but not predictable either. Not comet-like, not asteroid-like, not anything like the previous two interstellar visitors. Just strange. Some try to explain it as a phase angle effect, how the angle between sun, object and observer affects perceived brightness. But calculations didn't align. Others blamed equipment drift, but the pattern repeated and cross-confirmations arrived from other teams. It began to feel like a story told in pulses. Each spike in brightness coincided with a minute alteration in velocity. Almost imperceptible, but not invisible to the math. Velocity isn't something we see with eyes, but something we infer from timing, from shifts in spectral lines, from the way light subtly stretches and compresses as an object moves closer or farther away. And so, quietly, we began to see that this wasn't just a flickering object. It was moving differently, reacting or acting. No one could quite say. Theories multiplied, each tentative and softened with words like could, might, appears to. That's the language of science at the frontier. It's not doubt, it's care. One idea suggested internal collapse, that Thriss Atlas may have had a hollow structure, perhaps a porous core of ancient ice and rock, that caved in as solar heating reached a critical threshold. That would account for the light flare and the brief dust cloud that some infrared readings hinted at, but others were unconvinced. The timing was too precise. Why collapse just as it neared Mars? Why not earlier, when it passed closer to the Sun? Another suggestion: electrostatic discharge. In the vacuum of space, objects can build up charge, especially when moving rapidly through different magnetic environments. Mars has weak remnant magnetism in patches across its crust. Perhaps a sudden alignment triggered something. A release, a pulse, a ripple of static. It sounds far-fetched. But in the language of celestial mechanics, even far-fetched deserves attention. And then there was the trajectory twist. After the second flare, models showed a minor but distinct deviation. Not random, not wild, but angled. As if 3i Atlas had received a push, not from Mars, not from sunlight, but from within, or perhaps from something embedded. Was it venting? Was it shedding mass? Was a hidden fragment suddenly released? We don't know. You might picture it like this: a silent object coasting through blackness, then shuddering briefly, like a breath held too long, finally exhaled. Dust trails flicker into existence, then fade. The object dims again, slows, adjusts, continues, and we, far away, fragile and fascinated, watch the data scroll in. There's something profoundly humbling about observing such events in near real time. They unfold slowly by human standards, but across astronomical distances they happen fast. A shift of a few degrees in trajectory. A change in velocity by meters per second. Tiny, perhaps, but powerful. Over days and millions of kilometers, such changes alter destinies. If 3A Atlas had passed just slightly closer to Mars, the outcome might have been different. A tighter arc, a capture into orbit, a collision with a moon. But it didn't. It passed close enough to stir questions and distant enough to remain unknowable. Even its origin remains unclear. Its velocity confirms that it came from beyond our sun's gravity. But where? What distant star flung it toward us? How long has it been gliding through interstellar space? Some estimates suggest millions of years. Long enough for surface ice to be scoured by cosmic rays. Long enough for internal materials to crystallize, fracture and refreeze. Long enough to forget whatever system it once belonged to. And now, here it is, visiting Mars, flaring, bending, whispering. Perhaps the most haunting part is what we didn't see. After the event, telescopes searching for debris, tiny fragments, faint trails, found almost nothing. A brief trace, maybe. But no swarm, no cascade of breaking pieces. Just the original object, dimmer now, but intact. It reminds us how little it takes to stir us. A flicker of light, a bend in the arc, and suddenly, our entire world of quiet skywatching tilts into wonder. We return to our instruments, we refresh the plots, we trace the path hour by hour, and each time we come back to the same quiet truth. Something changed, something that shouldn't have, something no one expected, and somewhere in the silence near Mars, 3i Atlas keeps moving. If you could drift alongside it, just you and 3i Atlas in the stillness near Mars, you might see something delicate trailing behind it. Not flames or engines, nothing loud, just a thin haze of dust slipping backward into darkness. This is the quiet language of comets and icy bodies. As they near stars, they warm and the most volatile ices begin to sublime. Not melt, there's no liquid phase out here, but go straight from solid to vapour. That gas carries dust with it, forming a tail. Faint, wispy. A whisper pulled by sunlight and shaped by the solar wind. We think 3i Atlas may have a tail like this. Not bright, not photogenic, but there. In longer exposures, enhanced images show a diffuse elongation. Nothing symmetrical, nothing classic. But a suggestion, like the wake of something ancient parting the calm surface of a pond. What's more mysterious, though, is what this dust might be hiding. Comet tails often reveal the makeup of their cores. Spectroscopy lets us study their chemistry from afar. Carbon dioxide, water ice, silicates, ammonia. These are old friends to planetary scientists. But with 3i Atlas, early readings didn't match the usual spectral lines. Some wavelengths appeared muted, others were present when they shouldn't be. One possibility: coatings of dark organic material, simple carbon chains cooked slowly over millions of years in deep space. If that's true, then the dust tail isn't just a trail of evaporated ice. It's the faint breath of prebiotic material, a kind of cosmic ash scattered into the solar wind. But what if there's more than dust? Some astronomers now propose that the dim wake behind 3i Atlas might include structural debris. Not fragments from a violent breakup, there's no sign of that, but perhaps pieces sloughing off, like layers peeling from a dry husk. Ancient brittle material dislodged by heat stress. The kind of shedding a body might do after eons of travel. Others look deeper. They suspect the tail may be masking a secondary object, a smaller fragment, travelling just behind or beside the primary one. Too dim to resolve, too faint to prove, but capable perhaps of contributing to the irregular flares we've seen. These suggestions aren't without precedent. In 1993, Comet Shoemaker-Levy 9 broke apart under Jupiter's gravity. Its pieces formed a chain of impacts, a cosmic breadcrumb trail. More recently, comets like 332P Akea Murakami have been seen splitting mid-orbit. Space is fragile, ice fractures, dust disperses. But in 3i Atlas's case, nothing dramatic has happened, at least not yet. Just subtle signs, a deepening tail, a persistent haze, a flicker of motion not quite aligned with its core. We know, from past studies, that some comets carry satellite fragments for long distances. Sometimes these fragments orbit the parent body. Sometimes they simply trail behind like tired companions. If 3i Atlas has such a companion, it could be hiding in the tail, reflecting just enough light to suggest but not confirm its presence. Even without companions, the tail alone invites reflection. Imagine particles no larger than grains of sand. Released from the surface of a relic that predates Earth itself. They shimmer briefly in the sunlight near Mars, then drift outward. Some may fall into long, lazy solar orbits. Others might spiral toward the inner system. A few could be captured by Mars' thin atmosphere, burning up invisibly. In this way, 3 Atlas becomes more than a visitor. It becomes a contributor. Dust from beyond our solar system, mingling with our local environment. Not a threat, not a message, just an offering, quiet and unplanned. If we had sensors on Mars, delicate enough to detect upper atmosphere anomalies, we might find a fingerprint, a chemical shift. A transient molecule, but Mars is mostly quiet now. Only a few robotic observers remain. They didn't seem to notice, or if they did, their instruments were not tuned to catch it. That's the tragedy and beauty of cosmic moments. We often realize their meaning only after they pass. From Earth, our telescopes remain focused. space agencies have scheduled more observations in ultraviolet and sub-millimeter wavelengths. These can pierce through dust, analyse the temperatures and structures within a tail, and maybe, just maybe, reveal the source of the confusion. What excites researchers is the possibility that 3I Atlas's dust trail isn't static. It seems to shift over time, not just lengthening but changing shape, like something dynamic is stirring behind it, a wobble, a spiral, a curl. Could it be that this object is rotating irregularly, shedding dust in uneven bursts? Could it be tumbling in ways we can't easily measure? Or is there some hidden structure, perhaps vents or porous regions, causing material to be ejected in waves? All of these remain open questions. And then there's the silence. No signals, no energy pulses, no radio bursts, just light, gravity, and dust. That silence matters. It reminds us not everything has to shout to be interesting. Some things simply pass through, shedding secrets like soft ashes on the wind. Tonight, as you lie still, you might picture it. A dim traveller trailing a fragile veil, moving slowly past Mars, leaving behind dust that will drift for years, maybe decades. Some of it may settle into the inner solar system, some may never return. Some might, long from now, fall across our skies as faint meteors, unnoticed. And all of it began with a flicker, a shift, and a whisper of dust near a red planet. The farther we look, the deeper the sky seems to whisper. And as we trace the story of 3I Atlas, we begin to notice echoes, faint patterns in behaviour that feel oddly familiar. Not because we've seen this exact thing before, but because we've seen something like it, from a place we almost never reach, the Oort cloud. That vast ghostly halo of icy bodies, far beyond the orbits of Pluto or Neptune, remains largely invisible to us. It's more theory than sight, a shell of debris left over from the solar system's birth, stretching perhaps halfway to the nearest stars. No telescope has ever seen it directly, but every so often, something falls inward from that icy edge. We call these long-period comets. They plunge toward the sun, trailing vast tails, often never to return, and in many ways, 3I Atlas reminds us of them. Its path is interstellar, not just long period, but the signs feel similar. The odd brightening, the slow, delayed activity, the possible shedding of dust and surface material. These are the behaviours of cold objects waking up as they near a star for the first time in untold millennia. If the Oort cloud is the attic of our solar system, then 3I Atlas may come from the attic of another star, a distant neighbour we'll never see. And maybe, just maybe, its system had a version of the Oort cloud too, full of icy wanderers waiting to be nudged loose. That's one way these interstellar travellers begin their journey. A passing star, or a rogue planet, or even a galactic tide might disturb the balance. A tiny gravitational push sends an object drifting outward, until one day it escapes its home entirely. Drifting between stars isn't easy. Space is cold, vast, and quiet. The odds of anything from one system entering another are vanishingly small, but not zero, and so we watch 3I Atlas glide in, perhaps having left its origin 1 billion years ago. No propulsion, no aim, just inertia, gravity, and deep time. One of the haunting possibilities raised by astronomers is that 3I Atlas isn't alone, that it could be the first visible piece of a much larger structure, perhaps a cluster of fragments from a destroyed interstellar body. Some have even proposed it may be part of a stream of debris, a trail we just happen to intersect. If so, that would explain some of its stranger qualities, the irregular brightening, the unexplained motion, the flickering tail. It might be responding not only to the sun, but to subtle gravitational interactions with other, invisible companions nearby. There's a quiet term in planetary science: co-moving objects. These are bodies that travel together through space, often born from a common event. They don't always stay bound, but they echo each other's motion. If 3i Atlas belongs to such a group, then we may see another soon, or perhaps we've already seen one and failed to connect the dots. In fact, a few faint objects have recently been spotted on high-speed, hyperbolic paths through the solar system. Most are too dim or too brief to study closely, but perhaps in hindsight we'll realise they were kin to this one, part of a fading family crossing our sky like forgotten embers. It's an eerie thought, isn't it, that we might be catching only the middle of a much longer procession, that the true beginning happened far away and the conclusion lies beyond our reach. There's also the matter of its velocity. 3 Atlas isn't moving randomly. It has a clear inbound vector, a direction that points very faintly toward the constellation Lyra. No known star nearby fits as a perfect origin point, but perhaps it came from a now extinct system, or from a binary star where gravitational nudges are common, or even from the aftermath of a supernova cast out like a seed into the galaxy. And what is it bringing with it? If it is like an Oort cloud object, if it's a shell of ice and ancient carbon, then it may carry the oldest preserved chemistry in the galaxy. Some molecules in its dust might predate Earth. Others may resemble those seen in the outer solar system, formaldehyde, cyanides, even amino acid precursors. This doesn't mean life, of course, but it does mean possibility. The chemical ingredients for complexity, the cosmic pantry that planets like ours draw from. It's comforting in a strange way to imagine that systems far away from our own build their own versions of comets, of icy halos, of forgotten drifters. That the story we tell about our solar system might not be unique but shared, and so 3 Atlas becomes more than a mystery. It becomes a mirror, reflecting not only light, but history, chemistry, origin. Perhaps this is why we watch so closely, why the faint curve of its motion matters, why the soft trail of dust makes us sit up and squint through the night. We're not just observing an object, we're brushing against the edge of another world, one we'll never visit but which has sent us this quiet emissary. And somewhere behind it, perhaps, there are more. What if 3i Atlas isn't the only one? What if it never was? As astronomers pored over the data, its brightness, its irregular trajectory, the unexpected flares, some began to notice small anomalies in nearby star fields, faint smudges, temporary points of light, things that appeared for a few nights, then faded again. Most were discarded as background noise, but a few stayed, a few moved, and their motion matched a pattern. It's here that the story starts to bend into something even stranger, not sensational, nothing cinematic, just a quiet possibility that's difficult to shake. Some researchers now believe 3i Atlas may not be travelling entirely alone, that surrounding it, or trailing behind it, is a diffuse cloud of fellow travellers, interstellar debris that may have once been part of a larger whole. This isn't a new idea in astronomy. Fragmentation is common, especially with ancient icy bodies. Tidal forces, heat stress, collisions, these can all cause a once unified object to break apart. But when it happens in deep interstellar space, the fragments can drift for thousands, even millions of years before encountering another star. And if 3i Atlas did fragment long ago, then we may now be seeing the leading edge of that debris field. Imagine a swarm, not tightly packed, not obvious, just a loose constellation of rocky and icy fragments scattered across tens of thousands of kilometres, some larger, some barely detectable, their paths roughly aligned, their behaviour loosely coordinated by shared inertia. The possibility of such a swarm changes the nature of the story, because now, instead of a lone visitor stirring the silence near Mars, we have the edge of something larger, a soft spray of ancient matter entering our solar system like dust carried on a breeze. And this isn't just poetic speculation. Observatories like Pan-STARRS and the Vera Rubin Observatory, designed to track transients and faint motion, have started flagging more interstellar candidates. Most are quickly reclassified, but a few linger, a few resist explanation. They may not all be from the same origin as 3i Atlas, but the idea that we are beginning to detect these objects in greater numbers hints at a larger truth. Interstellar space may be more crowded than we once thought. There's a quiet irony in this. For so long we imagined the space between stars as utterly empty, just vacuum, dust and radiation. But perhaps it's not so barren after all. Perhaps it carries fragments of forgotten systems, the shrapnel of old collisions, the dust of broken moons, the seeds of what once were planets. If 3i Atlas is part of such a field, then its passage near Mars may have been accompanied, silently, by others. Maybe that explains some of the observations, the light anomalies, the thermal readings that didn't quite match, the faint changes in brightness that returned without warning. If multiple objects passed near the same region, the reflected light could blend, or distort, or echo. This has happened before. In 2017, a cluster of small near-Earth objects was discovered sharing nearly identical orbits. They were likely remnants of a larger body that fractured centuries ago. Earth occasionally passes through these swarms without notice, but when the sun hits just right, the pieces glow. Now imagine something like that, but coming from between the stars. Not aggressive, not coordinated, just drifting, falling through our system like forgotten snow. There's also the question of what this means for planetary defence. Objects like 3i Atlas are not threats in the traditional sense. They're too far, too slow, and usually too small. But the unpredictability of their companions raises quiet concern. If one fragment broke away and took a slightly different path, it could go unnoticed until very late. It's a reminder. We watch the sky not just out of wonder, but out of caution. And yet, there's beauty here too, because even the idea of a hidden swarm tells us something profound. It tells us that systems can break and scatter, that stars die and their children drift away, that across the galaxy, the record of countless worlds is being carried piece by piece through the void. Some of those pieces might be older than our sun. Some might contain trapped gas or sealed minerals. Some may hold isotopes or crystalline patterns we've never seen before, and every so often, one crosses paths with us. Perhaps Mars, in its silence, bore quiet witness to more than one visitor. Perhaps some of those fragments passed near its moons. Perhaps one or two entered temporary orbit, only to drift away again. We'll likely never know for sure, but the possibility changes how we think. No longer a single object on a lonely arc, 3i Atlas becomes the herald of a deeper current, a suggestion that the cosmos is not a place of isolated events, but of patterns, of families, of migrations too slow for the eye but written across eons in starlight and dust. So the next time a telescope catches a faint flicker in the sky, moving oddly, arriving from nowhere, we might lean in a little closer. We might wonder, is this one of them? Another ember from the same fire? And perhaps long after 3i Atlas has left us behind, another will follow, and another, and we will slowly begin to understand what kind of trail this really was. Mars has no eyes, no ears, and yet, we can't help but imagine it watching. As 3 Atlas passed nearby, glowing faintly in the reddish gloom, something about that planetary stillness made the whole encounter feel personal, quiet, almost reverent. Mars, after all, has always felt like a witness. It's close enough to observe, yet far enough to be mysterious. Its surface is marked by silence, dry riverbeds, fossilized dust storms, craters older than most life on Earth. And above it, for a brief moment, 3i Atlas drifted. In that time, it may have cast a flicker across Mars's sky, Not bright enough for a human eye to catch, perhaps, but just enough for orbiting sensors, those fragile scouts we've left hovering in the Martian atmosphere, to notice a change, a new shadow, a glint that hadn't been there before. We don't know for sure. Mars orbiters were not designed to track interstellar objects. Their instruments are tuned to soil, ice and wind. But data logs from that week are being quietly reviewed. Spectral anomalies, thermal spikes, unexpected reflections. Anything that might tell us whether Mars felt the visitor's presence. There's an intimacy to this kind of science. Not the kind with noise and urgency, but the kind that listens, that gathers traces, that patiently reads between the photons. Sometimes that's all we can do. Read the silence. It's a silence Mars knows well. The red planet has long been the stage for strange sightings. Telescopes of the 19th century recorded what were thought to be canals, straight lines crossing its surface. Later dismissed as optical illusion, these reports stirred imaginations. Then came the flares, brief flashes of light that some claimed to see. And even later, spacecraft began to detect odd reflective events. Nothing dramatic, just glints. Of course, most had earthly explanations: cosmic rays, instrument glitches, sun angles. But a few remained unexplained, not threatening, just curious. The kind of quiet phenomena that get logged then forgotten. And now, into this long story of Martian mystery, comes 3I Atlas. It did not crash. It did not roar. It barely passed by. But in the margins of observation it may have touched the Martian atmosphere in subtle ways. Not physically. There was too much distance for that. But through dust, light, and perhaps even magnetic fields. Mars has weak magnetism. Not a global field like Earth's, but regional anomalies, patches of old crust that still hold memory of a magnetic past. When solar wind brushes past these areas, the interaction can be complex, turbulent, sometimes even beautiful if you could see it. If 3I Atlas had its own electric charge, or if it was shedding ionized gas, the interaction might have disturbed Mars' exosphere, the ultra-thin outer layer of atmosphere. Maybe only slightly, maybe not at all. But again, the silence is not proof of absence. We may never know what Mars saw, but just imagining it, this quiet world, once full of water, now dusted with rust, watching a visitor from another star system is enough to slow the breath, to soften the night. There's something poetic about this pairing. Mars, the still, red elder of our solar system, cold, weathered, waiting. Atlas, the young traveller, not in age but in presence, new to us, unknown, passing by. Their orbits intersected for only a moment, a few days of near distance in the grand arc of space and time. But that moment drew countless eyes on Earth upward. Amateur astronomers, scientists, students, all watching Mars and its unusual guest. There's beauty in the idea that a planet no longer home to life might still play host to celestial encounters, that it can still be part of a narrative much larger than itself, and perhaps, in some ways, this encounter will leave a mark, not on the surface, but on the data, on the models, on our sense of what's possible. Because now, when we look at Mars, we might remember not just rovers and robots, not just lost oceans and potential microbes, but also that one night, quiet, red and distant, when something from beyond the stars passed nearby, unnoticed by rocks and dust, but witnessed by us. And maybe that's enough. We don't always need dramatic conclusions. Not everything must reveal its purpose. Sometimes presence is the gift. The fact that something was there, that we caught it, however faintly, that we felt it pass, and recorded the trace. As 3 Atlas continues on its journey, it leaves Mars behind. No orbit, no return, just a memory, perhaps only ours. And Mars returns to its stillness. Winds swirl, shadows stretch, moons rise and fall. But for a brief time, It was part of a larger story, a cosmic crossing, a whispered intersection of two lonely travellers, one ancient and planetary, the other icy and exiled. And high above them both, the sky remains unchanged, or maybe, just maybe, it remembers. There are moments in astronomy where silence speaks louder than discovery, not because we found something, but because something we expected never came. In the days following 3i Atlas's passage near Mars, our instruments began returning quieter and quieter data. No new fragments, no continuing flares, no trailing signals. The object had dimmed, not dramatically, not with collapse or rupture, but with a strange, soft withdrawal, as though it had slipped behind a veil. Astronomers often rely on predictability. They plot motion, brightness, reflection, all laid out in smooth, logical graphs. But when 3i Atlas dimmed again, the numbers stopped fitting. What had briefly brightened to a whisper of interest faded into near invisibility. Telescopes strained, infrared arrays hunted, and still it grew quieter. The James Webb Space Telescope tried again, scanning the cold sky near its projected coordinates. A few observations came through. Low temperature, no strong signature, flat lines. Not empty, but mute. Then came the gaps. Instruments that had previously tracked 3i Atlas with ease began reporting inconsistent returns. Ground-based telescopes in the southern hemisphere couldn't find it for hours. Then it would flicker back into view, then disappear again. Some blamed cloud cover, others solar interference. But orbital simulations didn't align with the observed timing of these dropouts. It was almost as if 3i Atlas was pulsing, not with energy, but with presence. There, then not there. Observed, then obscured. Was this due to rotation? Possibly. If the body has a regular albedo, areas that absorb rather than reflect, then its brightness could vary as it spins. But that should produce predictable intervals. This didn't. Then came a stranger suggestion: self-shadowing. Imagine an object with strange geometry, sharp ridges, hollow regions, perhaps even collapsed pockets. As it rotates, some surfaces might cast shadows across others. If sunlight doesn't strike consistently, then its reflection appears to blink. The whole body becomes a slow, drifting strobe, and in the faint emptiness near Mars, even a single lost degree of illumination can hide something completely. But one more explanation lingers, soft and unsettling. Maybe we weren't losing it because it was dimming. Maybe we were losing it because something was interfering with how its light travelled. There's a term in astrophysics, extinction. It describes the scattering or absorption of light by dust or gas between an object and the observer. It happens all the time, especially near nebulae or in the galactic plane. But here, in the relatively clean space near Mars, extinction should be minimal, unless, of course, the object brought its own. Some now believe that 3i Atlas may be surrounded by a field of ultrafine particles, microscopic dust that acts like a cloak. Not enough to scatter light in a traditional tail, but enough to muffle its reflection. A fog of its own making, one that shifts with orientation and solar pressure. This could explain the vanishing light, the strange pulses, the partial dropouts. It could even explain why some infrared readings detected cooler than expected temperatures. If the object is wrapped in its own shadow, its warmth might never reach us. It's not a new phenomenon. Some comets do this near perihelion. Their activity kicks up so much dust that their nucleus becomes obscured. But with 3i Atlas, we're seeing this behaviour far from the Sun. Which brings us back to the mystery. Why here? Why now? The area of space it moved through isn't special. No dense gas clouds, no known debris fields. Mars was nearby, but not close enough to influence dust behaviour, unless something else passed nearby, something small, faint, and untracked. This possibility has led a few observers to dig deeper into archived sky surveys. They're searching for brief flashes or transient shadows that might suggest a passing fragment, a companion, a trigger. So far, nothing definitive has emerged, but the absence is part of the story. We've sent signals toward 3i Atlas, of course, narrow beam radar pings, not to communicate, just to map, but no echoes came back. The surface may be too absorbent, or the shape too awkward, or the dust too dense. All we receive now is passive light, and even that is fading. It's difficult, emotionally, for scientists to let go of such objects. We grow attached. A discovery turns into a name into a story into a mystery. And then the sky grows quiet again. Perhaps it was always meant to be brief. A flicker in the void, a twist in a trajectory, a trail of faint dust here and gone, and perhaps that's enough. We don't need answers to feel something stir in us. The fact that something passed so near, the fact that it changed, even slightly, before fading. These are the threads that tie us to the cosmos, not with proof, but with presence. So now we wait. The next opportunity for observation will come in a few weeks, when Earth's position shifts just enough to glimpse 3i Atlas against a new patch of stars. We don't know if we'll see it again, not clearly, not for long, but we'll try. And in that effort, we find something gentle, something human, the wish to hold on to a mystery even as it fades from view. Across human history, the sky has been a stage for wonder and for worry. Long before telescopes, people looked upward and told stories about wandering stars, blazing comets, and lights that moved where they shouldn't. Some were omens, others gods. But always, these visitors stirred something deep. Now in the age of sensors and spectra, we still feel that stir, but we express it differently. We speak in models and measurements, probability curves and observational uncertainty. Yet when something like 3i Atlas flickers unexpectedly near Mars, that ancient pulse of awe returns, and it brings with it a sense of déjà vu. This isn't the first time we've watched a strange from the stars behave in ways we couldn't fully explain. In 1986, Halley's Comet returned with less outgassing than expected, and models had to be revised. In 2017, Oumuamua passed silently through the inner solar system, with a strange shape and an unexplained acceleration that puzzled even the most grounded researchers. In 2019, Tui Borisov lit up more brightly than anticipated, releasing cyanide and dust in its own pattern. Each time we responded with caution and wonder. Each time we were reminded how little we know about the things that drift in from elsewhere. But there's something about 3i Atlas that feels more delicate, more subtle, less dramatic, but more persistent in its refusal to be easily understood. It hasn't crashed. It hasn't exploded. It hasn't veered off course in a way that makes headlines. Instead, it has quietly contradicted our expectations, just enough to raise questions, just enough to feel strange. And this strangeness matters, even if it's not loud. The great astronomer Carl Sagan once said that the universe is not only stranger than we imagine, it's stranger than we can imagine. Objects like 3i Atlas are quiet reminders of that truth. They don't rewrite physics. But they tug at the edges of what we think is typical. They remind us that we live in a cosmos shaped by processes far older and perhaps far more complex than we can yet trace. One debate now unfolding in quiet corners of astrophysics concerns how to categorize these objects at all. Is 3i Atlas a comet, an asteroid, a fragment, or something else? The line between comet and asteroid is blurrier than most people realize. Comets are traditionally icy and active, asteroids rocky and inert. But we've found hybrid objects, main belt comets, dormant nuclei, icy centaurs. Some have dusty surfaces that conceal ice until they get close to the sun. Others contain barely any volatile material yet still flare unpredictably. 3i Atlas doesn't fit neatly into any of these bins. It came from outside the solar system, yes. It has shown some signs of activity, but its light curve, dust behaviour and temperature profile remain ambiguous. Some now suggest a new term, interstellar fragment, a catch-all category for things not shaped by our solar system's formation, but still made of the same universal ingredients. If that's true, then 3i Atlas might not be special in composition, just in context. It didn't form here, it isn't bound to our sun, it is a message from elsewhere, not written, not sent, but simply drifting. That's what makes these encounters profound, not what they say, but what they are. Because for every 3i Atlas we detect, there may be thousands more passing unnoticed, dim, fast, silent. We only catch them when everything aligns, trajectory, timing, observation. When our little world for a moment intersects with something older and colder. And the fact that we do catch them, even occasionally, speaks to how far we've come. We're a species that now tracks shadows across light years, that listens for the quietest pulses of distant stars, that notices when a flicker near Mars doesn't quite match the model. We've become attentive to the silence, and so, 3i Atlas joins a small but growing family of objects that carry no answers, only reminders. Reminders that the sky is still full of questions, that space is still full of motion, that the universe has not finished surprising us. It also nudges at a quieter realization. We may not be at the center of the story, not in time, not in structure, not in relevance. We are observers, brief and bright, looking outward and wondering. Perhaps somewhere, around another star, a being is watching one of our ancient comets drift by. Perhaps to them, it's just as strange, just as fleeting, just as silent. And maybe they too wonder where it came from. For now, all we can do is keep watching, keep listening, keep letting these soft impossibilities remind us how wide the universe is, and how lucky we are to have seen even a moment of it. Time behaves strangely in space. There are no clocks out there, just motion. Gravity makes the rules and light carries the memory. Everything else is interpretation. And yet, when something like 3i Atlas moves through our sky, time seems to stretch and fold in quiet, unexpected ways. When astronomers traced its journey near Mars, they began to notice small inconsistencies, not in where it was, but in when it should have been there. The object appeared slightly ahead of schedule, then slightly behind. Not enough to alarm, but enough to raise questions. You might expect this from a tumbling body. Irregular rotation can shift the way sunlight reflects, making it appear to wobble or blink as it moves. But this was different. The light didn't just pulse. It arrived early, or late, depending on the night. What causes this? One explanation involves an effect known as non-gravitational acceleration. When comets eject gas, the reaction pushes them in the opposite direction. Newton's third law, alive and well. For active comets, we see this all the time. Their orbits evolve slightly, requiring constant recalibration. But for 3i Atlas, we haven't seen the kind of vigorous activity that would explain the timing shifts. No visible jets, no dramatic outgassing, just subtle, irregular motion. This led some to revisit an idea once floated for Oumuamua, that of a symmetric outgassing, perhaps driven not by volatiles like water or carbon dioxide, but by more exotic materials. Materials that sublimate at lower temperatures or release gas in ways we're still learning to recognize. One proposal was molecular hydrogen, trapped deep within the object and venting slowly as it warmed. But we have no direct evidence of such gas. Another suggestion was thermal desorption, a slow release of particles from mineral surfaces as they absorb solar energy. These explanations are all plausible, but none are proven, and that's the thread that keeps appearing in every discussion around 3i Atlas. The evidence almost fits, almost explains, almost satisfies, almost. That's where time stretches, because with every unanswered question we spend more hours simulating, modelling, staring, trying to make sense of what the numbers suggest. In some models, a secondary body, small, unseen, might be orbiting the main one, periodically altering its motion just enough to explain the anomalies, but searches for such a companion have turned up nothing visible. In others, the object's spin state is chaotic, a non-principal axis rotation, or tumbling, that makes its centre of mass unpredictable. That would explain the light variation, but not necessarily the timing drift. Then came an even subtler idea. What if the timing variations weren't in the object's motion, but in our perception? Some have speculated that we're seeing an unusual phase curve, a way the object's surface reflects light differently at different angles, causing brightness to peak at unexpected times. It's the optical equivalent of walking around a sculpture and discovering the shadow isn't where you expected. But for this to explain everything, 3i Atlas would need a surface unlike anything we've catalogued, a mixture of high contrast reflectivity, shiny regions next to deep absorbers, not impossible, but rare, perhaps layered, perhaps fractured, perhaps ancient. It's in these spaces, between confirmed and speculative, that astronomy does its best dreaming. We begin to picture what the surface might look like, not smooth and icy, but cracked, ragged, with fissures where heat escapes, with dust that clings in odd places, a body shaped not by intention, but by billions of years drifting through cold and silence. You might imagine it now, spinning slowly, unevenly, as Mars recedes behind it, its shape only hinted at by changing light, its motion just slightly off. Not wrong, but untamed. Some scientists have compared these small deviations to orbital murmurs, minor variances that speak of deeper processes. Not loud, not violent, just quiet evidence that something more complex is happening beneath the dust. And still, no clear answers. What we're left with is this: a timeline redrawn by mystery, a passage near Mars that doesn't fit perfectly, a speed that refuses to stay constant, a set of coordinates that seems to shimmer ever so slightly when plotted. For now, 3i Atlas is still outbound, heading deeper into the solar system's mid-regions toward the orbit of Jupiter. If it survives that long, we'll have new angles, new shadows, new data, but it will grow fainter, harder to track, and time, as always, will keep stretching. There's something bittersweet about this part of the journey. We want to hold on to the object, to observe it longer, to understand it better, but like so many things in space, it's not ours to keep. We can only observe and wonder and write down what we saw. Like ancient astronomers marking the stars with charcoal and parchment, we still do our best work in the act of noticing. The moment we see a thing not as a number, but as a story. 3 Atlas is telling a quiet one. A story written in shifting shadows and strange delays. A story where time, like light, bends just slightly around mystery. And in that bend we feel something stir. Not fear, not urgency. Just the soft pull of curiosity, older than language. The kind that makes us tilt our heads at the night sky and ask again, what is that? To understand what something is, we often look at how it shines. Not metaphorically, but literally, by studying the light it reflects, refracts, and emits. And when it comes to distant objects like 3i Atlas, light becomes our only language. So we listen to it, carefully. Every evening observation, every telescope sweep, every orbital pass has contributed to what scientists call the light curve of 3i Atlas. It's a quiet graph, plotting brightness over time. Usually this graph tells us how fast an object spins, how it's shaped, what its surface might be made of, but 3i Atlas's light curve is unlike most others. Instead of the smooth, rhythmic rises and falls we might expect from a spinning rock or comet, its curve is jagged, uneven, pulsed in places where nothing should be pulsing. It brightens at odd moments, fades during sunward exposure, and sometimes seems to plateau for longer than it should. These aren't random flickers. They're too structured for noise, too irregular for known rotation models. Instead, they suggest complex interplay, perhaps between surface geometry, internal activity, and light. Astronomers have tried modelling the curve with different assumptions. Maybe it's a flattened disk tumbling end over end, or a long rod flipping like a baton. Or perhaps two lobes loosely bound together exchanging momentum. None of the models fit perfectly. One possibility is that 3i Atlas is precessing, wobbling slowly, like a spinning top just before it falls. Precession can cause brightness to change in a slow, drifting rhythm, especially if one hemisphere has a different surface material or texture than the other. Another possibility is volatile exposure cycles. If the object has a crust that cracks as it heats, then interior gases might escape in irregular bursts, clouding its surface and altering reflectivity until the particles drift away. This might also explain the muted albedo readings. Some wavelengths suggest the object is darker than expected, perhaps coated in tholin-like substances, those tarry organic residues that form over millennia in deep space. They don't reflect light well, but they do scatter it in strange ways. Then there are the spikes. On several nights, telescopes detected brief flashes in the infrared and near ultraviolet bands. Not enough to call flares, too weak, but still above background levels. These could be small jetting events, moments when gas briefly escaped and caught the sunlight at just the right angle. They could also be reflection flares, caused by angular surfaces acting like mirrors for a split second before tumbling out of alignment. If 3i Atlas has fractured faces or crystalline deposits, this might happen periodically, like a coin flipping slowly through light. And yet, none of this confirms a central truth. We still don't know what this object is made of. Spectral analysis has been confusing. Some data suggest carbon-rich compounds, others hint at silicates or hydrated minerals. A few rare readings even show absorption bands consistent with ammonia or cyanide-bearing molecules, things we see in outer solar system comets, but rarely this clearly. There's one especially strange dip in the spectrum around the 3.1 micron wavelength. That's where water ice tends to absorb. But in 3i Atlas, the dip is shallow, intermittent. Perhaps it has water ice buried under a dry shell. Perhaps that shell has pockets, vents, or thin layers that let light in just enough to mislead. Or maybe it's coated in something else entirely, something we haven't catalogued. After all, we've only studied a few interstellar objects up close. Most of our chemical libraries are based on solar system materials. Out there, between the stars, chemical weathering takes different forms. Radiation, micrometeorite impacts, cryogenic fractures, even passing shock waves from ancient supernovae might alter the surface of a drifting body in ways we can't replicate on Earth. So the light from 3i Atlas becomes a kind of quiet puzzle. Each reflection, a clue. Each flicker, a question. We stretch longer exposures, stacking images until the background melts away, hoping to glimpse more. And still, it dances just beyond clarity. Even polarization studies, the way light twists as it reflects, have been inconclusive. One night the readings suggest a fluffy porous surface, another night the signal tightens, as if reflecting off glassy crust. Some scientists whisper about layering, that the object may have once passed close to another star and developed a strange fused shell. Or perhaps it was part of something larger, and this fragment carries a stratified cross-section, dust, ice, organics, all weathered differently. We don't know. But there is one constant. The light keeps changing. Even now, as 3 Atlas moves farther from Mars, its brightness remains volatile. Not dramatic, but twitchy. As though the surface continues reacting. As though something beneath is still shifting. We may never get closer. No spacecraft are en route. No probes will fly beside it. All we have is this light, and maybe, in the end, that's all we need. Because light, once released, travels forever. It crosses space, slips through gravity, carries stories. It reaches us in quiet beams, and if we listen, truly listen, we can sometimes hear what it's trying to say. About distance, about change, about the ancient chemistry of forgotten stars. 3i Atlas doesn't speak in words, but it shines just enough, and in that shine, we glimpse a kind of memory. Sometimes it's not the light we see, but the chemicals hidden within it that speak the loudest. And with 3i Atlas, those chemical whispers are as elusive as they are enticing. When light reflects off a distant object, it carries with it traces of the molecules it's touched. Specific materials absorb light at specific wavelengths, leaving behind tiny gaps in the spectrum, what astronomers call absorption lines. By reading those lines, we can tell what an object is made of, even if it's millions of kilometers away. But the spectrum of 3i Atlas is a curious one. It shows hints of common volatiles. Yes, water ice, carbon dioxide, maybe ammonia. These are the same ingredients we find in many solar system comets, but they're faint, dull, almost buried under something else. Over time, deeper infrared observations began to notice unusual features, signals that don't match the typical profiles. In particular, one broad dip in the 4.5 to 5 micron range has caught attention. Some interpret it as a signature of complex carbon chains, things like acetylene, ethane, or polycyclic aromatic hydrocarbons. These molecules are not rare in the cosmos. We see them in gas clouds, in comets, in the atmospheres of outer planets. But the way they're appearing here, blended, flattened, erratic, suggests that they might be part of something more chemically evolved, something processed. One theory suggests that 3i Atlas has spent millennia drifting through cosmic rays, undergoing slow radiation chemistry. Over time, simple ices turn into more complex residues. Tholins, for example, a reddish tar-like material, can form this way. These residues aren't just dark, they're sticky, rich, and opaque. They coat the surfaces of comets in the outer solar system, they trap heat, they mute reflections. Perhaps 3i Atlas is coated in something like this, a deep, dusty veneer that conceals a more pristine interior. This would explain much. The inconsistent brightness, the confused spectra, the strange heat signature, lower than expected for an object that's passed near Mars. But here's where things grow more fascinating. Some spectra suggest trace amounts of nitriles, molecules containing carbon and nitrogen bonded together. These are essential precursors for amino acids and other building blocks of life. They're not proof of biology, of course, not even close. But they are signs of rich chemistry. Chemistry that might, in the right environment, become something more. And while we've seen these compounds in other places, Titan's atmosphere, for instance, it's still rare to see them in solid phase outer layers of a drifting object. Could 3i Atlas be carrying the raw ingredients of prebiotic chemistry across star systems? We don't know, but the idea is deeply compelling, because if so, then this isn't just a rock, it's a time capsule, a sealed archive of chemical evolution from a system we'll never visit, and even if it contains nothing more than dust and darkness, that still tells us something. It tells us that the galaxy is not chemically sterile, that the paths between stars are not empty roads, but rivers of drifting material. And once in a long while, those rivers intersect with us. It's possible that some of the molecules we see in 3i Atlas aren't even native to its original system. Interstellar space is not entirely passive. There are magnetic fields, radiation belts, collisions, clouds of gas that can slowly accrete onto surfaces. Over time, a body like this might collect a thin outer shell of borrowed chemistry, a layer not from its home, but from the journey. So what we're observing could be a mixture, the frozen core of one system, wrapped in the molecular dust of many others, each molecule a record of some silent passage through space. This perspective is deeply humbling, because we so often think of space as static, but it isn't. It flows. Slowly, quietly. it flows. Systems age, stars die, dust drifts, and somewhere within that motion, through Atlas formed. Then it was pushed, then it drifted, and now, here it is, shedding trace signals near a red planet under our gaze. We may never know where exactly it came from, but its chemistry speaks of cold places, dark times, long spans without light. It speaks of preservation, of stability, and maybe, just maybe, of the universality of carbon. If 3I Atlas carries prebiotic molecules, it's not alone. Other comets do too. But this one is different because it didn't come from our system. It wasn't shaped by our sun. Its atoms were born elsewhere, and yet we recognize them. The same bonds, the same elements, the same potential. Perhaps that's the quiet miracle of all this, that even between stars nature repeats itself, that carbon bonds, that molecules grow complex, that time fosters patterns. And so, as we listen to the spectral readings from this small dark body, we are not just doing science, we are doing archaeology on a galactic scale. We are reading the ashes of another system's chemistry, caught for a moment in our light. And even if that light fades, the story remains. From the moment it entered our neighbourhood, 3I Atlas carried uncertainty in its wake, but none of it feels chaotic, just quiet, as if the object itself isn't struggling, but drifting slowly, purposefully or not, toward an unknown fate. Now, with Mars behind it, attention shifts to what happens next. Where will it go? What will become of it? Will it remain intact? Will it fade from view? Or could some future nudge send it tumbling deeper into our system? We don't know, and that's the haunting beauty of orbital mechanics. It's both precise and precarious. Based on current models, 3I Atlas will continue outward on a loosely hyperbolic trajectory. It's moving fast enough that it won't remain bound to the sun, unless something changes. A gravitational encounter, a late-stage fragmenting event, a hidden gas release. These things could alter its path. But for now, it coasts along a line that bends away from the sun, slipping into the outer solar system. This isn't the first time we've seen an object slip past our star and disappear again into the dark. But it may be one of the more mysterious. Most comets that come inward leave behind visible signs. Bright tails, disintegrating fragments, dust streams that Earth might pass through decades later. But 3I Atlas has done little of that. It's left only questions. That lack of closure is unsettling to some, but to others, it's a kind of invitation, an open door to wonder. Because what if, just what if, this object doesn't leave? What if some unforeseen interaction lies ahead? A pass near a Trojan asteroid, a brush with Jupiter's influence, or, more subtly, a gradual shift due to continuous low-level outgassing. Some projections hint at a slight curve inward, not enough to capture it, but enough to complicate its departure. Perhaps it won't leave cleanly, perhaps it will slow. There's precedent. Oumuamua, despite its unbound path, displayed subtle non-gravitational acceleration. Some believe it vented gas in ways we never saw. Others think its shape allowed solar radiation pressure to push it more than expected. Could 3I Atlas follow the same pattern? If so, it could begin to linger in regions we hadn't anticipated, maybe near the orbit of Jupiter or Saturn or beyond. Not forever, but long enough to interact with something else, some unseen particle field, some pocket of dust, some cold echo of a planetary moon's magnetotail. The solar system is not empty. Even beyond the planets, the regions of the Kuiper Belt and scattered disk hold countless objects, icy bodies, ghostly worlds, shadows of early formation. If 3I Atlas drifts through these regions, it might in time collide with something, or pass near enough to leave a mark. There's even a whisper of a chance, remote but not impossible, that it could be gently slowed and captured. Not by a planet, but by the sun itself. For an interstellar object to be captured by our solar system, its speed must reduce enough for the sun's gravity to overcome its escape momentum. Usually, this would require a significant energy loss, a close pass to a massive planet, or perhaps a rare three-body interaction. But if 3I Atlas continues shedding material, even slowly, even invisibly, that loss might accumulate. Tiny pushes day after day could draw its arc into a softer curve, a long elliptical orbit instead of an open hyperbola. If that happened, we wouldn't know immediately. It would take years to confirm. But one day, we might look up and realize it's coming back. That idea carries a certain gravity of its own, because a returning interstellar object is not just rare, it's unprecedented. It would give us time to plan, time to study, time, perhaps, to send something out to meet it. Imagine that. A mission launched not to a distant planet, but to an ancient visitor who refused to leave. A relic of another star system now caught in our orbit, waiting. But for now, all of that remains possibility. What we know is simpler. 3I Atlas is still moving, still dimming, still whispering questions into the void. And we, back here on Earth, continue to update the models, adjust the projections, extend the arcs, hoping that in its fading trail we'll find a pattern that tells us what comes next. There's a strange humility in this part of the story. We built great machines to understand the universe. We launched telescopes beyond the moon, crafted sensors that detect individual photons, and still, this one small object drifts past us, partially seen, partially understood, partially gone. It's a reminder that knowledge is always incomplete, that certainty is always partial, that in space things don't have to end with clarity, sometimes they just end with distance, and yet that's not a failure. It's part of what makes the story meaningful. Because 3I Atlas is not here to be solved, it's here to be witnessed, to slip past Mars in silence, to change its path without explanation, to shine strangely, then fade. And to leave us, not with answers, but with the beautiful burden of wonder. Even as 3I Atlas recedes from Mars and glides into the deepening dark, it becomes part of a larger neighbourhood, one that few ever think about yet quietly surrounds us with quiet complexity. This neighbourhood isn't the realm of planets or moons, it's not the bright corridor of the inner solar system. Instead, it's filled with the forgotten and the faint, the small drifting bodies that orbit quietly in the shadowed outskirts, the Trojans, the Centaurs, and the scattered kin of the Kuiper Belt. These regions aren't empty. They're quiet archives of formation and disturbance, zones shaped by the gravity of giants and the fingerprints of chaos. And now, 3I Atlas passes through this web. First come the Trojans, clusters of asteroids that share the orbit of Jupiter, nestled in stable points known as Lagrange regions. They don't orbit the planet directly. Instead, they balance between Jupiter and the Sun, like dust caught between the push of two winds. The Trojans are ancient, perhaps as old as Jupiter itself. Some believe they formed closer to the Sun, then were flung outward as the planets migrated. Others think they arrived from farther out, trapped during the early instability of the solar system. As 3 Atlas approaches this region, it's not expected to pass through a core cluster, but even a peripheral encounter with Trojan space brings questions. These regions are gravitational basins, quiet traps. If 3I Atlas has companions, as some models now suggest, those fragments might be drawn inward, caught, hidden. Then there are the Centaurs, bodies that wander between Jupiter and Neptune. They're chaotic in orbital terms. Many are on unstable paths. Some originated as Kuiper Belt objects. Others may be ex-comets, slowly devolving into rock and silence. The Centaur population includes some of the strangest bodies we've seen, like Chariklo, which has its own ring system, or Chiron, which sometimes flares like a comet despite being classified as an asteroid. If 3 Atlas's path drifts near this population, it could blend into statistical obscurity. just another strange light in a sky of anomalies, or it could be noticed, tracked, folded into models that map how chaos moves through cold space. Finally, there is the Kuiper Belt, the outer garden of the solar system, home to Pluto, Eris, Makemake, and countless smaller nameless worlds. Here, sunlight is weak, time is slow, and everything carries the hush of distance. The Kuiper Belt is dense compared to interstellar space, but even so, it's easy for a drifting object to pass through undetected, unless it reflects well, unless it shines just so, unless we're already watching. What makes this part of the journey significant is not that 3i Atlas is expected to collide or interact, but that it moves through these zones as a contrast. It is not of them. It does not share their origin. The bodies in the Kuiper Belt, the Centaurs, the Trojans, they all formed from the same protoplanetary disk that birthed Earth. Their isotopic fingerprints match our own. They carry the echoes of our early chemistry. But 3i Atlas is foreign. Its ratios may differ. Its crystalline structures might be wrong for this star. Its orbital energy isn't solar, it's galactic. And yet, in the coming months and years, it will drift among these siblings, like a distant cousin passing through an old hometown. The others won't notice, but we will. Because this moment, this convergence, is rare. There is a quiet possibility that in passing through these regions, 3i Atlas might in some minute way change them. Perhaps a faint dust stream is left behind, slowly drawn toward a Trojan cluster. Perhaps a fragment is dislodged and enters a centaur-like orbit. Perhaps a long-forgotten Kuiper Belt body is nudged slightly, imperceptibly in a new direction, one that won't become apparent for 100 years. That's how influence works in deep space. Not with noise or explosion, but with patience. A slow ripple, a new curve, a shadow that wasn't there before. And it works both ways. Just as 3i Atlas may leave a mark on these quiet zones, so too may they leave one on it. A passing dust grain, a glancing collision, a shift in trajectory too small for us to detect, but real. In this way, the solar system becomes a kind of soft maze, a field of possibilities, a test of how well a visitor can pass through without being changed, or changing others, and we, back on Earth, continue to watch. We model the approach angles, we compare simulations, we stretch our instruments to see just a little farther, a little longer. We do this not because we expect drama, but because we value subtlety. Because in the space between planets there is a kind of poetry, not written in words but in motion, in paths and arcs, in small forces felt across long distances, and 3 Atlas, in its quiet journey, is now part of that poem, a guest among relics, a whisper moving through echoes, not quite belonging and yet, for a time, sharing the same sky. Every question about 3i Atlas eventually leads to this. What do we really know? And how much of that knowledge rests on consensus, on models, on inferences gently layered over incomplete data? As the object glides farther from our familiar worlds, deeper into the realm of Trojans and Centaurs, the scientific community begins to diverge, not in hostility, but in tone, in interpretation, in how they frame the unknowns. Some argue for caution. They believe 3i Atlas is behaving exactly as it should, a natural object from another star system, reacting to heat, to sunlight, to gravity. That every flicker, every twist in its path has precedent. That nothing is new, only our attention. Others are less certain. They point to inconsistencies, light curves that refuse to stabilize, spectra that contradict themselves, a trajectory that doesn't quite add up unless we assume mass loss or hidden rotation or internal voids. They're not making wild claims, just asking quiet questions. That's the beauty and the tension of astronomy at the edge. There's no immediate way to verify a theory, no sample to touch, no lever to pull, just patterns, light, equations, and the human mind trying to fit them all together. Debates are unfolding now in conference calls, journal drafts, and private research forums. What exactly is 3i Atlas? Is it a comet? A fragment? Something older, colder, stranger? There is even a disagreement about when it left its origin system. Some orbital models, extrapolated backward, suggest it may have been drifting for hundreds of millions of years. Others propose a more recent ejection, perhaps after a planetary disruption, or the collapse of a distant binary star. Some even wonder if it was once part of a planetary moon, ripped free during a cataclysm, flung outward like shrapnel from a forgotten war in another solar system. These debates are not speculative indulgences, they are the slow, deliberate machinery of science doing its work. They echo earlier conversations about Oumuamua, whether its acceleration was from venting or radiation pressure, whether its shape was cigar-like, pancake-like, or simply unknown, whether it even was a natural object at all. Those questions stirred deep public interest, but they also left scars in the community, divides between those who urged restraint and those who dared to push further into uncertainty. With 3i Atlas, some of those tensions have returned softly. Is it responsible to suggest that we don't fully understand what we're seeing? Or does that feed too quickly into speculation? Where is the line between scientific openness and narrative seduction? Some researchers propose we need a new classification system altogether, that objects like 3i Atlas, interstellar, ambiguous, chemically rich but visually faint, deserve their own category. Transient interstellar aggregates, one draft calls them. Unbound relics, suggests another. There's no agreement yet. Only the shared sense that our current labels, comet, asteroid, minor planet, are insufficient. This debate isn't about prestige, it's about clarity. When our language fails, our understanding follows, and in the case of 3i Atlas, even the way we describe it shapes how we observe it. If we call it a comet, we expect outgassing. If we call it an asteroid, we expect inertness. If we call it a fragment, we imply loss. But what if it's something else? Something in between? Or something we've never named at all? This is where science and philosophy begin to touch. Softly. Cautiously. Because what we call things matters, not just for cataloguing, but for how we think. And when we encounter something that doesn't behave quite the way it should, we're faced with a choice. Bend the data to fit the model, or stretch the model to embrace the unknown. With 3i Atlas, more and more researchers are choosing the latter. They're beginning to ask, what would we expect from an object that formed around a different kind of star? That accreted in a different disk, under different pressures, with different mineral abundances. Would it fracture differently? Would it scatter light in new ways? Would its chemistry, its magnetism, its internal structure, would all of it feel just a little bit off? And if so, how many others like it have passed us by unseen? For centuries we assumed interstellar visitors were rare beyond reason. One per millennium perhaps. But Oumuamua came, then 2i Borisov, now 3i Atlas. The timeline is tightening, detection methods are improving, and perhaps the sky has always been more crowded than we dared believe. So the debate continues, not loud, not sharp, but steady. It's not just about 3i Atlas anymore, it's about what it represents. A doorway, a riddle, a mirror held up to our assumptions, and above all a reminder. We are still learning, still listening, still, after all these centuries of looking up, only beginning to understand what moves through the quiet dark. Even among the gentlest corners of scientific thought, shadows sometimes stretch further than expected. And with Through Atlas, a quiet unease now lingers, not because it is violent or threatening, but because it continues to defy full understanding. It's in the pattern of its motion, the flicker of its brightness, the unplaceable chemistry in its spectral trails, and perhaps most hauntingly in what it hasn't done. No tail like a textbook comet, no clean arc like a classic asteroid, no closure, no decay, just a lingering uncertainty that wraps around its faint path like fog. As the object recedes toward the outer planets, some have begun to whisper about more speculative possibilities, not loudly, not dramatically, but in the quiet way researchers sometimes speak late at night, with data still open and doubts not yet resolved. Could 3i Atlas be something broken? A fragment not just of a comet, but of a more complex structure, like the fractured husk of a former moon, or the outlying piece of a larger layered body? Could it be a remnant of something artificial, not in the science fiction sense, but in the way a structure once ordered can outlast its original purpose? These are not mainstream ideas. They are gentle questions, hypotheses whispered at the edges of models that don't quite close, and even those asking them do so with scientific caution, but they ask because the normal frameworks don't entirely hold. There is precedent for unexpected structures in space. In 2020, astronomers discovered a quasi-satellite of Earth that turned out to be not a rock, but a relic from a 1960s rocket stage, caught in temporary orbit by accident. The solar system, it seems, can hold on to things longer than we expect. Now with 3i Atlas, the idea of structure returns, not artificial, not engineered, but perhaps architectured by time. Maybe it's hollow. Maybe it's layered in such a way that light behaves oddly on approach. Maybe it fractured long ago and we're seeing one piece tumble in a way that feels inconsistent, only because we don't see the rest. Or perhaps, just perhaps, it passed through something before it reached us. A gas cloud, a debris field, a slow shockwave from a stellar remnant. And maybe that passage altered its shell, gave it properties our instruments weren't ready to expect. Some researchers have started calling it a ghost object. Not literally, of course, not supernatural, but ghostly in behaviour. An object whose presence is measurable, yet never fully stable, fading in and out of clean classification, obscuring itself through partial shadow and partial truth. There's something poetic about that phrase. A ghost, moving among gravitational giants, slipping between light and reflection, never staying still long enough for the picture to sharpen. That poetry, however, doesn't mean surrender. Scientists continue their work. Models are refined weekly. Observations are timed with increasing precision, aiming to catch even the smallest irregularity in the object's retreat. New surveys are being coordinated. Instruments that had been focused on distant galaxies are now sparing a few minutes each night to search for traces, shadows, glints, returns, any final light that 3i Atlas might cast before it fades from view. We may never know what it is, not fully, but we know what it isn't. It isn't typical, it isn't linear, and it isn't leaving cleanly. That irregularity alone makes it valuable. In science, anomalies are not mistakes. They are signals. They mark the edges of the map where old assumptions begin to fray. We approach them not with fear, but with reverence, with care. And even as the major journals hold back on dramatic claims, the private conversations among planetary scientists have shifted. There's more humility now, more openness to the idea that our classifications are incomplete. There's also a growing awareness of how little we understand about what's between the stars. We know so much about stars themselves, about their life cycles, their flares, their deaths. But what fills the vast ocean between them? What forms in that emptiness? What drifts through it for 1 billion years? Maybe 3 Atlas came from such a place, not from a planetary nursery, but from the cold, slow drift between them, not born in heat, but shaped in darkness. If that's true, it could be older than our solar system, older than Earth, a remnant not of creation, but of afterthought, and that might explain why it doesn't behave like a familiar object, because perhaps it isn't, and that's what makes it quietly terrifying, not in any way that threatens, but in the way it humbles, in the way it reminds us that the universe does not owe us answers, that some things drift by not to teach us, but simply to be, to cast a glint across the sky, to pass near Mars, to flicker, to bend, to vanish. and to leave behind a silence louder than explanation. If Mars could remember, it might keep a memory of 3i Atlas. Not a vivid one, no streak across its sky, no searing impact, no long shadow etched in dust, just a faint impression, a moment when something cold and uninvited passed nearby, and then was gone. But planets don't remember. They have no eyes, no thoughts, only records written in dust, rock and time. Still, we do. We remember for them. We remember that 3i Atlas crossed near Mars in stillness, that it stirred questions we hadn't prepared for, that it moved as though trying to remain unseen, and yet some part of it was always visible, always saying I am here, even if only faintly. Now that Visitor continues outward, its arc stretching behind it, its signals growing weaker, but something strange lingers, not in the data, but in the sense that something changed during its passage. Not in it, in us. In science, there's often a before and after, before an observation, and after its implications settle. With 3i Atlas, that threshold is soft, no big discovery, no smoking gun, just the slow, creeping realization that the sky is not as predictable as we thought, that visitors can pass silently, that our neighbourhood is porous. For Mars, this was not the first close pass of a strange object. In the past, long before humans walked, long before Earth grew forests, Mars was likely brushed by other wanderers. Some may have left fragments in orbit, others may have struck long ago, their craters now hidden under wind and age. But 3 Atlas left no crater, only curiosity. Even so, it added a page to Mars's silent record, one we're now tasked with translating. And as we peer through the data from orbiters and telescopes, we're beginning to ask if the Martian environment recorded anything subtle. Did any thin dust layer shift? Did a charged particle stream stir faint aurorae? Did the high-altitude atmosphere react, however faintly, to passing ions or reflected radiation? These are delicate questions, not ones we'll answer quickly. But the idea that 3i Atlas brushed the edge of another world and may have altered it, even microscopically, feels significant, because it reframes the way we think about interaction. Too often we imagine influence in terms of collisions, flares, explosions, but space has its own language. Gentle fields, dust trails, invisible shifts in electrostatic balance, a few microns of motion over millions of kilometers, and Mars, with its wafer-thin sky and old bones, is the perfect place to observe such things. Already, teams are revisiting datasets from Mars orbiters that were active during the pass, instruments measuring ion density, atmospheric temperature gradients, light scattering in the upper atmosphere. No one is expecting fireworks, but in quiet science, even the absence of change becomes data. Was 3i Atlas just another speck in a long chain of interstellar debris? Or was it the tip of something more? We return to the idea of the swarm, the possibility that 3i Atlas was only the leading edge of a stretched-out family of objects. Perhaps one or more fragments trailed behind, invisible to our scopes. Perhaps one dipped closer to Mars than the primary body. Perhaps one still lingers. The solar system doesn't always keep clean records. Gravity has memory, but it doesn't explain everything. In fact, some small orbital anomalies have recently been logged around Mars. Drifts in tiny artificial satellites, small rebalancing needed in station-keeping calculations. These could be routine, they could be software drift, solar pressure. But they also raise eyebrows. Could a passing fragment have ever so slightly influenced a satellite's motion? Could dust from 3i Atlas have interfered with signal calibration? Could a solar flare, triggered or modulated by the object's tail, have thrown off a measurement? None of these theories have yet been confirmed, most likely never will be. But their asking changes the field, because the moment we consider that one interstellar object, unbound, unpredictable, might influence our robotic presence on another planet, the distances feel smaller, the The cosmos feels closer. The wall between stars and planets softens. It's not fear that follows this realization, just attention, an attentiveness to possibility, a widening of the lens. This is how science grows, not by sudden leaps but by quiet adjustments. Like watching shadows shift and realizing the light has changed, and 3i Atlas in passing Mars may have changed the light just a little. Not its brightness, not its temperature, but our sense of it. We now know that interstellar objects do not merely pass through the solar system, they touch it. Not physically perhaps, but gravitationally, magnetically, chemically, psychologically. They touch our maps, our models, our categories. They move through not just space, but thinking. So now Mars holds, somewhere in its long red silence, a chapter written not by dust or water, but by a passerby from elsewhere. A single visitor, whose name we gave and whose story we're still learning to tell. As 3 Atlas fades beyond the orbit of Mars, we find ourselves looking not just outward, but inward, toward the ways these rare visitors quietly reshape how we think about space, time, and the strange comfort of uncertainty. We want answers. That's human. But in astronomy, sometimes the most valuable thing an object can give us is not clarity, it's perspective. And 3 Atlas has given us that in abundance. What began as a faint interstellar blur has become something more, a reminder that even with all our instruments and equations, the cosmos remains full of gentle riddles, not locked behind walls but floating in the open, just far enough away to make us stretch. Now, as the object moves away, astronomers are doing what they always do when an anomaly slips from view. They archive. They catalogue every observation, every spectrum, every pixel, every calculated deflection. All of it carefully dated, annotated, stored. Because one day, perhaps a decade from now, or 100, another object will appear, and it too will behave oddly, and someone will pull out the records of 3i Atlas and ask, is this the same? This is how science remembers, not with certainty, but with patterns, with echoes. Already, in long-term orbital simulations, the object's trajectory is being traced out beyond Saturn, past Uranus, and into the quiet regions where sunlight is pale and time feels thicker. Out there, among the soft, slow ice of the Kuiper Belt, 3i Atlas may drift for centuries. Perhaps it will disintegrate. Perhaps it will loop around the sun in a long, slow arc. Perhaps it will leave us entirely. But whether it returns or not, it has changed something fundamental. Not in the planets, not in the sky, but in us. It has reminded us that even the vast machinery of the solar system is still porous, still open, still capable of receiving whispers from stars we cannot name. And in doing so, it has returned us, quietly, gently, to humility. We like to think we've mapped the sky, that we understand the flow of objects, that we can predict what belongs and what does not. But when something like this arrives, unbound, faint, behaving not quite as expected, we're reminded that the sky does not exist to confirm our expectations. It moves with its own rhythms, its own ages. The truth is, we don't know how many more like 3i Atlas are out there, passing silently between systems. We only detect the brightest, the closest, the most cooperative. The rest remain in darkness, sliding past unseen. But if 3 interstellar objects have arrived within just a few years of each other, Oumuamua, Borisov, now Atlas, how many more are slipping by, unrecognized? Not just once in a lifetime, but perhaps once a month, once a week, drifting across our line of sight, too dim or too fast to catch. This realization has begun to shape new efforts. Next-generation surveys, such as the Vera C. Rubin Observatory's Legacy Survey of Space and Time, are preparing to scan the sky every few nights with unprecedented depth. Their goal isn't just to study known populations, it's to catch the unexpected, the fast, the flickering, the foreign. And the lessons of 3i Atlas will guide those observations. We now know what to look for, or rather, what not to expect, because it's not always the dramatic that teaches us the most. Sometimes it's the object that almost slipped away without notice, the one that made no sound, the one that left no glowing trail. It's the nearly invisible one that makes us question what else we've missed. And that is perhaps the most enduring gift 3i Atlas has offered. Not knowledge, but humility. Not facts, but questions. Not certainty, but the quiet realization that the cosmos is far older, deeper, and more unpredictable than our models will ever fully contain. That in itself is a kind of answer, and so we close our telescopes one by one, not with disappointment, but with gratitude. We tracked it. We studied it. We didn't understand it fully, and that's okay, because we saw it. And in that brief seeing, we were reminded, once again, of our place, not as masters of the universe, but as watchers beneath a velvet sky. Now the object is nearly gone. 3i Atlas, once just a whisper on the edge of our senses, is receding into the quiet, fainter each day, farther, the last of its brightness smudged against background stars, too dim for the human eye, barely within reach of our most sensitive arrays. There will be no dramatic finale, no sudden parting flare, no vanishing act, just distance, and then absence. But what remains is not a loss, it's a presence, subtle but lasting. A thread added to the tapestry of what we now know, and what we now suspect. In the early days of its detection, 3i Atlas was a curiosity. By the time it reached Mars, it had become a mystery, and now, as it passes into the outer dark, it becomes something else altogether, a reminder that the universe is not a sealed box, that there are doorways between stars, that material, frozen, fractured, foreign, can travel untold distances and still arrive near us, not to announce itself, but simply to pass through. In its quietest way, 3i's Atlas has expanded the boundaries of what we consider local. Because how do you define our solar system if objects like this can enter it? Is the border marked by the sun's gravity, by the heliosphere, or by something softer, like attention? Maybe what defines home is not walls or edges, but which stories we choose to notice. And for a time, we noticed this one. There are new theories now, fresh models, adjustments to orbital assumptions, research groups convening across time zones, comparing notes, discussing ways to identify others like it sooner, to distinguish them more clearly from the thousands of near-Earth objects that swirl around us. But beyond the science, 3i Atlas has also left behind a tone, a softness in how we speak of the sky. Because it didn't just pass through space, it passed through our thinking. It made us pause, made us wonder, not just what is that, but how often does this happen without us knowing? It shook the idea that our skies are fully charted. Even now, its precise origin remains a mystery. It did not arrive from the direction of a specific star, nor does its trajectory trace cleanly to any known system. Galactic drift has erased that path. Perhaps it was born in the wake of a collapsing binary, or ejected from a system where a gas giant migrated too quickly, or maybe it's older than any system still burning, just a long cold splinter from some ancient world still intact. We may never know, and maybe that's all right. Because not every visitor needs to tell us where it came from. Some just need to be seen. There's a word astronomers sometimes use when discussing fading light: extinction. It sounds dramatic, but it's really just a measure of how much light is lost between source and sensor. Dust, gas, shadows, all play a role. And now, 3i Atlas is undergoing its own kind of extinction. Not a dying, but a dimming. Not an ending, but a soft fade. like the last light at the edge of a horizon you didn't know you were watching, still it leaves traces, in memory, in data, in the long, quiet equations that will one day be adjusted ever so slightly because of this visitor. Years from now, someone may run a simulation, and their model will behave just a bit more accurately, because we once watched 3i Atlas pass near Mars, because we recorded how it moved, how it didn't behave like it should, and maybe, when the next one comes, and it will, we'll be ready to notice sooner, to listen more carefully, to name it with more reverence, because we'll remember this one, the one that flickered, the one that bent, the one that whispered and vanished without ever fully revealing its nature. 3i Atlas didn't change the solar system, but it changed how we see the solar system, and that too is a kind of orbit, a looping back to humility, a gravitational curve around curiosity itself. Now, as we close this journey beneath the stars, let's return to where we began. Not with noise, but with stillness. You might picture the dark once more, Mars glowing faintly in the distance, and 3 Atlas slipping away, its light now faded beyond the reach of sight, but not beyond memory. A path drawn in soft curves across the vast quiet. We've wandered with it through gravity wells and dust trails, through spectral riddles and fragile theories. And all the while, we've done what we do best, not just observed, but wondered. And that wonder, gentle and slow, is what we carry back with us now. Let the images settle. A visitor from deep time, gliding past a silent planet, brushing against models that no longer held. Let the questions linger. Where did it come from? What else is out there? What might still be arriving? We don't need all the answers tonight, because the sky isn't a test to be solved, it's a presence to drift alongside. So take a breath, feel the stillness return, know that the universe keeps its rhythm, even when we sleep, and that somewhere, far out past the last reflected light, 3i Atlas continues on, quiet, slow, unbound. Thank you for keeping watch with us tonight. If this kind of quiet wonder helps you rest, I'd be grateful if you tap like or subscribe, no pressure at all. Wherever you are, whatever time it is, I hope you feel a little closer to the stars. Sweet dreams.